All right, welcome to the test review session. It's sure to be an exciting evening. We have x to the negative fourth, y to the zero power, and z to the sixth. Um, the first thing I think if I were approaching this problem is I would be thinking about this y to the zero power. Y to the zero power, as probably you are thinking right now, is 1. Anything to the zero power is 1. And since this is a series of multiplication, these terms are being multiplied, really this you can kind of think of this as just going away because it's going to be 1. So anything times 1, of course, will be its identity. Don't worry about it. So we have x to the negative fourth times z to the sixth. Well, z to the sixth can stay right where it's at. X to the negative fourth power, to get rid of the power that is negative, we're going to move this whole term down below into the denominator where it becomes positive, and we're done. I noticed some people in the test that put 1 times z to the sixth. They were thinking about the y to the zero power. That's fine too, but you would eventually you would simplify this just to z to the sixth power. You wouldn't leave 1 multiplied by z to the sixth. Next problem. It's 7 multiplied by k to the negative eighth multiplied by h to the third. Again, there are no like terms. We have a k term and an h term, so they can't be combined. We can't add the negative 8, the 3. They can't be combined. So we'll keep what's positive up in the numerator. And this term here, the k to the negative eighth power, that will move down into the denominator so it can become a positive 8. And that's the most you can do with that one. Here we have negative 3 to the negative third power. Again, you're going to take and move this whole thing, because it's the negative third power, we'll move down into the denominator. Again, you can imagine that there's this fraction bar there, if you will. It's going to move down below. Well, when it moves down, to keep its placeholder, we'll keep a 1 up there. Now we have negative 3, still negative 3. But again, the power now is going to be positive once we've moved it down into the denominator. So we have 1 over negative 3 to the third power, which is 1 over negative 3 to the third power is 27, and it's negative. Again, think about this here as being negative 3 times negative 3. I should use parentheses, it was easier, and times negative 3. Negatives. Okay, negative 3 times negative 3 is 9. 9 times negative 3, negative 27. Okay, so that is that problem. Moving on to number 4, we have 7 to the negative second, y to the negative fourth. Again, there are no like terms to combine anything. We just are trying to deal with these negative exponents. And once again, we can move everything down below. 7 to the second power, y to the fourth power. By moving them into the denominator, they become positive. Had they been in the denominator as negatives, you move them up into the numerator and they become positive. It's just a matter of moving them to the opposite location in the fraction. So we have 7 to the second power, which is 49. Y to the fourth power stays. And we're done. Last in this video is this problem here, which looks more complicated than it really is. We're going to look at this q to the negative fourth power. We can move that up top in the numerator. It will become positive. P to the second power will stay right where it's at. R to the zero power is 1. And again, you could write that initially if it made you happy. R to 0, 1. 1 times p to the second power is just going to leave you p to the second power. So in the end, you have q to the fourth over p to the second.